Hello, hello. Sorry, I'm running 5 minutes behind. You guys sitting there waiting patiently for me. I apologize about that. I was trying to get everything set up. I've been gone a while and all of my settings were whacked out. So hold on 1 second. You're going to see some camera shifts and all kinds of stuff here in just a second. But how's everybody doing? Can y'all hear me? Am I plugged in? Am I wired up? I think so. But how's everybody doing? You guys and girls okay? I was up north in Indiana. We had our open house event up there, and we had some new accessories that we were getting worked out for the new machines, the CNCs and stuff. Got a very cool new carousel ATC that Digital Wood Carvers rocking on their CNC machines. So all kinds of fun stuff, and just getting back, getting settled in, and getting caught up and stuff down here in Florida. And so now we're back with our classes. So I know we've been away for a while. All right, give me just a quick second. Let me stand by just a second. Let me see if I can find. Let me see if I can find what in the world I'm looking for. All right, all right. Okay, so let's see here. You're going to see the screen go blank in just a moment. You're going to, well, not go blank. It's going to have my book cover on it. Give me just a second, ladies and gentlemen. We are stand by your man. There, I'm back. Okay. So there we go. Sorry, guys and girls, trying to get this tighten right here. Ooh. All those green screen effects. Okay, we'll deal with that for just right now. In just a second, we'll get back to it. It'll get me by. I just didn't want to have the green screen in the background. Okay. I'll get it figured out and fixed in just a moment. How's everybody doing? Everybody doing all right? I am, I'll tell you what now, a whooped puppy. been staying quite busy and loving every minute of it. Don't get me wrong, but it's been insane and all that stuff. But I'm glad to get back to it. Now, tonight's topic is going to be a good one. We're going to be talking about your cut qualities on the CNC machine. And we're going to talk about, how, things that can contribute to bad cuts and how we can fix them. Now, what I want to do is I want to give me a second because the gold members get links to join me on camera if they want to. And I forgot to post that link. Let me grab that really quickly for them. Give me a second here. Invite, copy that link, create a post for gold members, paste that link. And then, sorry guys and girls, I'm really running behind. I got my butt kicked today. Copy, paste, and space, and post. All right, gold members, if you want to, you're more than welcome to. The link is out there in the community page on YouTube and all that wonderful jazz. So, all right. So now, can get back to it. Sorry, ladies and gentlemen, it was kind of a race to the last moment to get everything cranking. And it was just Trying to get everything going here. I really did have, I do have a good opening and to make you hang with me for that first 30 seconds and all that wonderful stuff. I had all the taglines, I had everything ready to go. I say that, but and the fun thing about it was on the notes and everything that I made, I had for myself. It literally said at the top of the notes, literally, swear to goodness, start strong, no rambling. Yeah, that was my advice to myself. Oh my goodness gracious, Lord of mercy. Start strong, no rambling, and then of course I'm rushing around the last minute. All right, let's take a deep breath, have some tea, and then we'll get cranking because I know you guys, your time is important too. I love live events for this reason because it's just so raw and unfiltered and uncut. All right, so let me ask you something. Have you ever carved anything on your CNC, right? Pulled it off or, moved your gantry out of the way and you were looking at it and you thought, well, why does that look like the Vectric preview? Or, I wasn't expecting it to look like that and everything. And as you're looking at it, whether it be a V-carve or model cut or anything like that. Let me get the guys, give them approved in here. How y'all doing? Hello, Ronnie. Good to see you. Right. Pulled it off or, moved your gantry out of the way and you were looking at it and you thought, well, can you hear me okay? Make sure everybody can hear me. And if you, wonderful. Okay. I just want to make sure I'm not rambling and all, but you get to looking at that board, or project, whatever it is you pull off and everything. And, the edges, they're a little fuzzy. The details, aren't that crisp. Maybe it was a 3D carving, and you get a little bit of chip out or a rough cut on a piece of plywood or a dado cut or a rabbet or something, and then you start thinking immediately. Tell me if this is you or not, but you start thinking that it may have something to do with your machine. Like, is it my machine? Something wrong? I know that a lot of times, in a lot of different situations, the first thing that we want to do is we want to blame, the machine, not blame. We want to point to the machine, point the finger like, oh, there's a problem with the machine. And I'm just here to tell you that it's probably not your machine, right? Most likely it's going to be your process or your setup and all. And so, what I'm going to talk about tonight with you is kind of help you determine, why your cuts may not look. And we'll talk about what professional versus non-professional. I use the word professional, but why they don't look clean, why they don't look, sharp and things like that. And more importantly, we're going to talk about how to fix it and stuff. By the end of this, you'll know exactly what to change, hopefully, to get cleaner cuts. Let's fingers crossed if I do my job right. We're going to get better results off your CNC, and it doesn't matter what CNC. Okay, so that's the whole point. And my glass, I can't see a blessed thing, but that's the whole point. I look weird without my glasses on, but I don't care if it's a $500 CNC machine or a $500,000 CNC machine. The CNC machines are very obedient. They're going to follow instructions. They're going to do exactly what they're told to do. And if they're following bad instructions, doesn't matter what machine you're on, you're going to get bad results. Okay. And a lot of times we want to point to the machine, and a lot of times it's really not that. And so I want to try to take away a little bit of that myth from you all, from people's thinking. And I want to make sure that you're not immediately looking at the wrong areas and that we start looking at the right areas and see what we can figure out together. Whether it be our setup, our bits, our feeds and speed, conditions in our toolpaths. all of the things, our toolpath decisions, you know, whether we're climb cutting or conventional cutting and all that wonderful jazz. We're going to talk about all that tonight, and we're going to see if we can start to put a little bit of an answer a little bit of, you know, put answers to things. So the what we want to do is we want to get started with the fact. Let me pull this over, and I want to start. There's a new thing that I'm using called gamma slides, and I want to. It's like you'll see it pop up on the screen here in just a minute. I'm loving the gamma slides, so give me just a second, and let me get that slide presentation going, because it's going to be my visual impact, if you will, my visual reinforcement on this stuff. And all. Gamma, where are you at, buddy? Okay. And let's open up the presenter. All right. Now, for you all, I'm going to put you on my other screen. Let me drag and drop you over here. And we'll get you going. And then we will share my screen. So anyway, Ronnie, how are y'all doing these last couple of weeks? Ain't seen and heard you. You been doing all right?
Yeah, everything's going good, Laney. Everything's going good. Learning a little bit about 3D printing, slicing models, and all that good stuff.
All right. Bear with me a second. Hold on a second. I was wondering, I was like, why can't I hear Ronnie talk? Hold on a second. I was like, why can't I hear Ronnie talking? I shaved. My ear had shaving cream in it. Hold on. Say something again, Ronnie.
Testing 1, 2, 3.
Yeah, man. There we go.
All right.
That's so stupid. Okay. Anyhow, let's get you guys off to the side. That's so crazy. Oh my God. Shaving cream in my ear. Okay. And let me make sure that the stream is running the proper audio. Whoa. Hold on a second. Ooh. I didn't blow y'all's ears out just now, did I?
Not too bad.
Oh my God. I just had a whistle blowing. Okay, so let me look at my audio really quick. My microphone is Black Magic. That's on. And my earpiece is on. And my camera's on. Wonderful. Okay, great. Now, got the presentation on the screen here. Why your CNCs don't look professional. All right. One of the things I love about gamma slides is the I mean, it's really a great it's much better than PowerPoint and everything. It kind of helped me kind of lay some things out and stuff. So most CNC problems, they're not, you know, within the machine. It doesn't matter. Again, like I said, it doesn't matter what machine you're on. And I say it all the time. It's very, very true. Okay. So CNC machines are obedient. They're going to do exactly what they're told to do. Nothing more, nothing less. And if they're getting bad instructions, bad G code, bad toolpaths, bad setup, bad clamping, home not proper, all of these things, right? All of these things that tell it what to do. If there's any little misstep, any little thing missed, it's like a thread that you pull that just, kind of unravels, right? So bad results typically come from 3 areas. All right. They come from tooling. So dull tools, maybe a tool that somehow or another has been run, a lot, And so it's literally if you put it under a microscope, you can start to see chipped edges and things like that. So which kind of, can fall in the same line as a dull tool. And I wish I had one of those microscopes and be able to put, like a show tooling under a microscope just to show, what, a bit that's your go-to bit that you run all the time, what it actually looks like at the blade level and stuff, from heat buildup or whatever the case may be. So we want to, first we want to kind of consider our tools, the tool edges and the sharpness and everything. But then also we want to toolpaths. Toolpaths would be number 2 of the 3 items that it typically falls into. And then material behavior. Believe it or not, material behavior plays a major role in our results and stuff as well too. And so your machine, again, I'm not going to harp on it, but it's doing exactly what it's told to do, right? So we want to make sure that hopefully by the end of the night that we are giving it good instructions. So if we look at the screen and everything on the slide and stuff, I'm not going to read everything verbatim or any of that stuff, but before we start blaming the machine, like, oh, it's just a hobby unit, benchtop unit, or, it's whatever. Let's look at our setup and everything. So setup relates to your material positioning on your table, how it's being held down. So squaring and held down, how we're zeroed out, right? We want to make sure that we're all good there. If your machine has limit switches, and I'll ask some of the guys here that run machines with limit switches and everything, but homing is very important. As soon as you power on the machine, home your machine, because the machine, there's a lot of safeties, a lot of features, a lot of things built into it. And if the machine doesn't know where it is, sometimes it could trigger, safeties or stops or soft limits or this or that. When you're like, dude, I've only moved an inch, or hell, I can't even move at all as soon as I power on the machine, or whatever the case may be. So homing is a very critical thing. And both you two that are on the screen, I'm pointing to you like you can see me, but both of you two that are on the screen with me, you both have machines with, limit switches and things. And Ronnie, would you agree with that statement that homing is a very important start of the process, making sure the machine knows where it's at and what it's doing?
Oh, absolutely. It's the first thing I do after I power up.
Yep. So every time you power up the machine, home the machine, even if you go to lunch, you shut down, you come back, you turn on home your machine, because understand something for you guys and girls that do have limit switches on. You have what's called your machine home, and then you have your work offset. Work offset is where you set your XYZ zeros on your material. And when you home, it doesn't reset your work offset or lose your work offset. That work offset is literally that position, whether it be the center of the board or the corner of the board. The 0, 0 for your work offset is a known location, a known position from your machine 0, right? 0 point, your limit switch is on. So when you home the machine, it does not reset or lose your XY position. You can literally home your machine and then tell it to return back to its work offset, and it'll go right back where it is. So whenever you, long story short, the whole point of that is home your machine every time you turn it on. Let the machine figure itself out. That way it knows exactly where to go and where to be and all that stuff. So your setup is very important. On your clamping, make sure that you've got secure clamping, and make sure your clamping is not in the way where it'll actually interfere with the actual carving and stuff, right? So setup is important. Tooling. So many times, and I put this in the slide, the wrong bit is used, and I'll talk about that in just a second. It could be the wrong tool, a dull tool. It could be I've seen people load toolpaths and forget to change the tool, or change the tool and forget to load toolpaths and screw things up, whatever the case may be. But let's talk about the wrong tool for a second. And where I most commonly see this is in ball nose and tapered ball nose cuts, like 3D finish and things. Someone will have in their Vectric software a toolpath calculated using an 1/8 inch ball nose, yet at their machine they have an 1/8 inch ball nose that has a 1/4 inch shank, not realizing that that is a tapered ball nose. So there's an actual angle from that 1/4 inch shank. There's an actual taper angle down to that 1/8 inch ball. And that angle, that side angle, whatever it be, 6.3 degrees, 5.4 degrees, whatever it might be for that tool, that is accounted for and calculated in the tool path. And if we put in a ball nose in our tool path, a ball nose, that term means that the tip of the bit and the shank are the same diameter. So an 1/8 inch ball nose has an 1/8 inch shank. 1/4 inch ball nose had a 1/4 inch shank, that kind of thing, right? And so if we do program that tool path for an 1/8 inch ball, but we're using a tapered ball, those angles, those side angles aren't accounted for, and that kind of throws the tool path off, which could affect, carving, into details that shouldn't have been carved, or carving in areas that, that were supposed to be carved, but not because they were missed or what have you. So that can really affect it. So that's what I mean by wrong tool. Also, many times I've seen people, program something not realizing that they were programming for a 90-degree, 1.5-inch diameter bit, but they're using a 90-degree 1/4 inch diameter bit in their tool, and that actually plays a role. Plays a role in the depth of cut and things like that. Still 90 and 90 is still 90 degrees, but it affects depth of cut and things like that as well. So tooling, wrong tool, dull tool, or maybe we don't have the tool seated properly in the collet or clamped down, and the tool slips out of the collet. God forbid, in the middle of the run, that could ruin something instantly. Now, another thing is the toolpath strategy, right? Our toolpath, and toolpath strategy is just how we set up the toolpath, right? So strategy would be: are we cutting on the inside of the line, outside the line, on the line? Are we doing a climb cut or a conventional cut? Things like that. So some of these things, cut directions and stuff like that, just like I say in the slide here, they're silent killers, right? They're just, you don't realize it, but you're going to get a different effect, or you're going to get a different result, based on the cut direction or whatever the situation may be. So good news is all three of these fixable, right? We are absolutely going to work on fixing those. And so the what we want is I'm going to define what I mean when I say professional, okay, right? The word, what professional looks like when I use that word. It doesn't mean, that doesn't mean that you have to have been running a machine for years, and you're a professional. What I mean by that is, what it actually means is that you're getting sharp edges, right? Clean pockets, your minimal fuzzies, right? Minimal fuzzies on the edge, minimal tear out and things like that. Clean transitions, from one process to another. Clean edges, clean pockets, very little tear out, and minimal sanding requirements, right? In a lot of cases, if you do things right, there's a lot of scenarios where you can pull right off the CNC and have absolutely very little sanding to do to get it finished ready. It just depends. Now, with that, there's some give and take as far as run times and all that. Sometimes we rush through things and all that, but when I say the word professional, that's what I'm talking about. Clean cuts, sanding, minimal sanding requirements, nice edges, clean pockets, minimal fuzzing, all that stuff. So that's what we're shooting for, right? So if your first instinct is sanding, then something's gone wrong upstream, right? We should be minimal sanding right off the CNC if we do things right and everything, and we all want to strive for that and stuff like that. But if it's like, it'll sand out, or these little lines and tool marks or whatever, then again, something's gone wrong up here, right? So in the process and stuff. So the And again, on the screen, just kind of these are visuals. They're not meant to be read, line for line, but I'm ad-libbing a little bit of what's on there and all. But we're talking about clean corners and pocket details. We're talking about minimal sanding required, all of that wonderful stuff, right? And everything, consistent depth, and all. That's when I say professional results. That's what I'm referring to. I'm not referring to your skill level or how long you've been a carver or any of that stuff, or how expensive your machine is. Like I said, I can, with the right setup and everything, I swear to God, I can go online and I can grab a Fox Alien if I want. No offense to Fox Alien, but I could put a CNC together and I could get good, clean, professional results on that machine with the right setup and everything. And again, that's machine setup too. Now, don't get me wrong, but the right setup and all that stuff, I can get good results off of it as well. So having nothing to do with you as far as your skill level or anything like that. Okay, so just make sure we understand that. And then what we typically have is what the situation is and what's possibly causing it, right? So kind of cause and effect, if you will, right? And so let me just kind of point out on this slide here what we're going to be talking about today, and what my promise to you is. I hope I can keep this promise, and you're going to have to hold me to it, right? But we're going to talk about fuzzy or hairy edges on your cuts, tear out on the entry and exit points. We're going to talk about uneven or inconsistent cut depths, burn marks on the profiles, chipping on your fine lettering and all that stuff. And hopefully at the end of this 90 minutes, that's my big promise, is we're going to try to keep this within a 90-minute period or so, close to. But by the end of the session, that you may have a solid understanding on exactly why things might be happening, or what to look for, why things are happening, and step by step, possibly on how to fix that stuff, right? So no fluff, right? I'm going to try to do my best to help with that. Okay, so let's get into it. And fuzzing, okay? Let's start with the fuzzier, edges and all. And what this is, it's the fuzzies. You might see them at the bottom of V cuts, right in the middle of the V. You could see it on the edge of a dado or a rabbit or a mortise or something, right on the edge of your solid wood. I'm not talking right at this moment. I'm not talking about tear out, where you're actually like chipping veneers and things. I'm just talking about where you have those fuzzies left behind, and you almost have to kind of take a 220 sandpaper or something to kind of just knock off those fuzzies, and they fall right off and all that stuff. But why are they there to begin with, right? And what you'll typically find is it has nothing to do with the material. In a lot of cases, sometimes, well, can't really say that. Sometimes it has to do with material. Your soft woods tend to be a little bit more fuzzier than your hardwoods and things like that. But what you typically have is when the bit's cutting and everything, we are like a digital wood carver. We'll admit it. I'll admit it. We're very conservative on our cutting speeds and feeds. On our settings and everything. We say, hey, slow things down. But then people in the real world, they're like, speed things up. They want to go faster because they want to get things done and all of that stuff. And the two don't really meet up very well, right? So there's that fine area where we're not going too slow, our feed rates and stuff. So what's happening is, if we're going too slow, the feed rate through the wood and everything, we're rubbing. And what you can hear that by the high squill of your router bit. It's wailing at you like a hungry puppy at feeding time, right? Just screaming at you and things like that. And what that is think of a turkey call. like a box turkey call. When you're rubbing the wood, that little handle and everything on the top of that box, work, and I can't make a turkey sound, but it's rubbing. And what's happening is that bit is spinning. The RPMs are up a little high, and that bit is spinning, but it's not moving through the wood fast enough, and it's not actually taking chips. It's not taking a cut. It's rubbing, and that rubbing leads to squealing, and that also tends to lead to rough edges and things, because we're not shearing away those nice chips and fibers and things. We're not sharing them away. We're just rubbing and kind of burning and all. And so typically we'll see that happening and all. And what we want to do is we want to kind of slow down the RPMs a bit and increase the feed rate. We don't want to do both of those at the same time. If you change your RPMs and you increase your feed rate at the same time, you have no clue what was contributing to your issue. Was it going too slow, or was it the bit spinning too fast? If you change both of those numbers at the same time, which one solved the problem if the problem got solved? So you want to speed up your feed rate, increase your feed rate, keep the RPMs as they are and everything. Give yourself a little bit of a run time, let it run for a bit and observe the cut. Listen to the change in the tone and the sound. Your ear is going to pick up mistakes before your eyes do. And we want to, see if there's any effect. And if there is, whether it be good or bad, we adjust accordingly. And then if we're getting there, but we're not quite there yet, then we can start to adjust the RPMs. And somebody, if they got a router, your RPMs are controlled at the router dial on the top of the router. If you have a spindle, you can control it in the software as you're cutting and things. But then we want to start to lower down or slow down. You want to slow down your RPMs before you speed them up. But we want to start to slow down the RPMs and then observe the cut. And our cut is either going to improve or it's going to get worse, right? And then we got to adjust accordingly until we kind of find that fine tuning. And so a lot of times it's difficult to do in the middle of a run when you're carving and all. Sometimes it's okay, you can do, but if we're in a situation where the feed rate is constantly changing, we're slowing down and speeding up when we're carving and all, it's really hard to kind of make the adjustments on the fly and really kind of observe the cut and everything. But if we're doing like a pocket cut where it's just wah, 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 and it's just squealing at you and howling at you and all, we could make some adjustments and we could listen and we could see that very clearly and all. So there's a lot of times we're adjusting on the fly, and that's why this is where test always kind of helps improve. And make notes of what material you're cutting, what bits you're using, what feeds you're doing, what RPMs, and that'll help in everything. Now, aside from maybe going a little bit too slow, causing that fuzzing and everything, that rubbing and stuff, that fuzzing and all, dull bits. That bit it's literally passing the fibers. It's spinning, but that bit is got some dull edges and it's not really shearing the cut. It might be taking some of the chip, but it's not taking it all. And what's left behind is the little fuzzies that are kind of curling up and stuff, and everything. So we're not really shearing that chip off and having it fly away and all that stuff. Is just kind of some of it's going, some of it's sticking, and the result is what we refer to as fuzziness, right? Or hairy edges and things. And then another big one is the wrong number of flutes. Rule here now, 3 flutes for woodworking, wood cutting, 3 flutes or less, and things like that. 3 flutes is kind of an ideal, 2 to 3 flutes. Anything really above that, 4 flute, 5 flute, 6 flute, whatever, you're now into kind of non-ferrous metal milling and stuff like that. So your metal mills that you would typically see at, metal factories or milling shops and things like that, they have, tools with lots of flutes and everything. And, when they're taking that metal chips and shavings and all, they need those flutes and stuff. But in woodworking, too many flutes can lead to issues. So 2 to 3 flutes. Sometimes there's what's also called an O flute or a single flute bit. O flute and single flute are not the same type of bit, but an O flute bit, and then there's a single flute bit. But typically 2 flute, like a 2 flute upcut spiral or downcut spiral or compression, or a 3 flute V bit and things like that. That's your sweet spots, right? 4 flute, not really for woodworking and all that stuff, and up, leave that for your metal milling and things like that and everything. So wrong number of flutes, for the material that you're cutting, wood, plastic, and all that stuff. Too many flutes, not a good thing. Okay, so let's look at the, you guys have been probably reading over my shoulder and all that stuff as we go, but the root cause, typically is a sharp bit that is, that's got the, it's got the correct settings for the right chip load and all that stuff. Shears, cleans up, nice and clean. But if we're going the wrong RPMs, the wrong feed rate, our chip load isn't correctly, or if our bit is dull, then we're gonna start to see those fuzzies and fibers and all that wonderful jazz. Okay, so the tip, that quick check, true. I don't have great fingernails, but I do have fingernails. But when you run your finger across the cut, the edge of a cut and everything, if it hooks you and everything, then adjust your chip load and everything. You should have a nice clean cut. You should be able to kind of, graze your fingernail across that material and not get hung up and everything, and all. If you're getting hung up and all, then, you may need to tweak your feed rate, RPMs, that chip load, whether it doesn't have to be a big tweak. It could be just minor, but that's a true statement. Okay, so now, aside from those fuzzies and all that stuff, tear out, right? Veneer tear out, or just tear. It could be solid wood too, so it's not necessarily always a veneer. But we're tearing out our cuts and our edges and things like that. And so what these are referred to are, they could be small chunks, but they're literally chunks. You're literally, those fibers are like, chunked up, splintered, whatever you want to word. I use the word chunks and splinters in it, right? So it's a tear in the fiber, the wood surface, and it's kind of tear and almost folded back and everything. That's tear out, right? You will see tear out typically along edge cuts, rabbet cuts, dados, grooves, mortises, the inside edge of pocket cuts of it, and that, which is a form of a dado, rabbet, or groove, a pocket cut, right? And also profile cuts, when you're cutting out the outside edges and stuff like that of your material, that tear out and stuff. So that's where you're going to pretty much see it along the grain. Okay. Plywood is absolutely one of the most vulnerable materials to tear out and everything. And so to get into bits real quick, typically we're going to be using a downcut spiral for plywood, unless we're cutting all the way through and we need that clean cut on both ends. Then we're going to talk compression bit. It has the upcut and the downcut on the same, bit. It's called a compression cutter. And that is what we want to get that clean, minimal, tear out finish on both edges, that mirror finish on both edges. But typically, if we're just doing pocket cuts in plywood and we're not cutting all the way through, then it's a downcut bit. It's going to help kind of push those fibers down. So a nice sharp downcut bit that's with the right feed rates and all, pristine cuts, not really a lot of fuzzy or chipping or any of that stuff that we got to deal with. And so we got to also talk about, your cut directions. So climb cut versus conventional. The most all of your cuts, and here I probably say it wrong sometimes and everything and all this stuff, but typically metal milling and surface cutting. And surface cutting, when I say surface cutting, we're probably still climb cutting, but the way the toolpath is set up, it's set up as a conventional cut, but it's most likely still a climb cut. But we want to climb cut most of our cuts it's going to produce a cleaner cut, less wear and tear on the bit, less heat buildup, so longer tool life, if you will. But it is going to produce the cleanest results on the cuts and everything versus a conventional carve and everything. When we're metal milling and all, we want to conventionally cut. When we're woodworking and all, we typically lean to a better cut quality and less wear and tear on the bit. So we typically lean to climb cut being our default. And so our cut direction relative to the grain, too much of a pass depth plays a role too. And that one's kind of a hard balance, because there's people out there, I'm watching YouTube videos and everything, and they're like really pushing that I can do this in one pass, 3/4 inch in one pass and all that stuff. And that's great. That's wonderful for testing your machine's capabilities and limits and everything. Plow the hell out of it, right? But when it comes to carvings and cuttings and things that you're going to be selling and all, you hopefully are selling quality items. We want quality coming off of the CNC versus quantity. Yes, we want to get things done, but if we have to spend time at the workbench, sanding, cleaning up, getting it finished ready and all that stuff, where that time could have been spent, a little bit of extra time on the machine could have been spent to reduce my hands-on time, I'm going to be better off money-wise, profit-wise, and things like that. Your time, your labor, whoever's working for you, labor, that labor is always going to be worse as far as like, we don't want a lot of hands-on labor. I'd much rather have more machine time. I'd rather my machine run longer over the employee's hands on the wood, that trade-off. Because my machine, when we're talking about pricing and money and all, kind of getting detouring just a moment, when we're talking about pricing and everything, believe it or not, you might think in your head, oh, my machine runtime is $30 an hour or $40 an hour. It takes this much money to, turn my machine on, whatever the case may be, whatever it is, that's actually not true. There's what you want to make and your labor and everything, plus, what covers all your overhead costs and all that stuff. And in the world of the machine time, what your machine cost is per hour and per minute, realistically on most hobby machines and everything, you're probably right around $5 an hour to about 13 cents a minute for machine time, believe it or not. And if you ever want to challenge me on that, we can, one day we'll have a class on like strict pricing, and it's proven math, so I can pretty much prove that to you. It's not just making a bold statement. It's true. When we're talking about how much it costs to run my machine, we're actually talking about how much we want to make. Labor that covers what it pays our whatever it is, minimum wage, or our $21 an hour, our $30 an hour, for all of the labor that we do and everything and involved setup and all that stuff that covers our overhead and all. That's what we're really talking about. But when it comes to actual machine time, that number is actually significantly lower. Okay, anyway, we're not getting into pricing tonight. So, but pass depth is important, right? Too deep of a pass isn't, good, but also too little of a pass isn't good too. If we're taking too many shallow passes, we're going around that same area too many times in a concentrated area. We're building up heat. Now we're burning and doling and all that stuff, and we'll get into that a little bit later in the slide. But so it's not always. There's a fine balance. There really is, and that's the hard part as us as woodworkers and engineers and machinists and whatever you want to call us. Learning that balance. So. Why things happen? Why do we get tear out on our edges and stuff? So too much of a depth per pass, too deep, right? So it forces the wood. We're forcing the wood to cut at this pass depth and everything, depending on how fast our bit is spinning and how fast we're moving and everything. And we're literally where the force to take that deep, big chip exceeds the strength of the wood, depending on what type, especially softwoods and things like that. And so we get chip out, we get tear out, we get fragile little edges that just break off and fly away. So we want to try to, balance our pass steps and everything. And so as far as why it happens, I got a third bullet point here as far as, no sacrificial layer or hold down at the, edge of the cut. Basically the sacrificial layer or hold down typically refers to like a masking, like an worm mask or something like that, or some people use masking tape to do a cut and it pulls cleanly and blah, blah, blah. But it's a sacrificial layer. All right. So wood is strong, right? We're strongest along the grain. We look at how wood is laid out when we're building furniture and things like that. What our break points are, where we're weakest and things like that. So going across the grain, we're typically weaker than going, along with the grain. And when our bits exit, a cut, it can leverage up or break up those fibers and stuff in those weak areas and all, instead of slicing through them, leading back to the previous slides about the dull bits and things like that, or just again, too much of a pass step and all that stuff. But it can cause that chipping. And in the wrong cut direction, if we're doing climb versus conventional, where climb or conventional, we're kind of going with the rotation of the bit versus against the rotation of the bit, and a climb cut, we're actually causing more issues. We're forcing that, to happen. I hope any of this makes sense. I'm trying to, this the best I can do to verbally teach and with a little bit of a visual. So now what I don't want to do is bore you to death, right? So let's talk about let's I just want to make a kind of a key statement here and everything. I want you to do your best to, and this video will be out there forever, maybe to go back and listen to and all that stuff, or whatever the case may be. And I can make this slide available to people and stuff like that, as well as like a little handout, little PDF. But what I'm hoping is that we just don't see the problem. I'm hoping that we see the problem and then we learn how to fix it, right? That's our kind of our goal and everything. And so I'm just trying to give you visuals, verbal visuals that you can try to mentalize or kind of relate maybe to some of the cuts you've had in the past. And hopefully maybe when you see those again coming up in your next carves and all, I've given you a little something to kind of think about on what to do, or maybe what to look for, or what to try to correct something if you see it, if you catch it, right away and stuff. And so your tool is doing the cutting, whether it be your pass depth is too deep, feed rate too fast, RPM spinning too slow. If any of that's wrong, then nothing else matters. There's fundamentals that we got to try to learn that we know every day. We do it all the time, but when we start to hone those in, and we start developing little systems for ourselves and understanding what to adjust, what not to adjust, that's when we start seeing results, and we start seeing them come off the table, and it's like, holy cow, what have I been doing, all this time? And it's, I didn't realize I could get cuts this great, off the machine and things like that. But some of us can't make that change because, hey, I can't, my shop's got to go. And I'm being pushed to do this or get these out and all that stuff. And what I would prefer is quality over quantity, right? So everybody hopefully would prefer that. I would much rather my machine run longer, a little slower, this and that. versus, you know, having to do all that work and clean up at the end. So now let's talk about really quickly about another issue, and it's refer it to as rounded or washed out details. It is basically the cut quality, not fuzzy, not chipped out or anything, but it's kind of the detail and what have you is a little bit off. It's not it's not where it's supposed to be, whether it be a sharp cut on a V carve, you know, a nice crisp edge, or it be a detail in a 3D model, whatever it may be, that things are kind of like well, that model, she had eyes, but I really can't see them that well. So it's kind of muddled details and things. And a lot of that stuff has, you know, will have to do with your file and your design and your model. But I mean, if I've got a good crisp model that I'm carving or something that's got beautiful detail with the right bit, with the right settings and everything, I could really get some beautiful detail. But I come off and things look a little, what's the word? Not passe, but a little muddled and things like that. What we can do is, you know, like what we can look at, and here's we'll go off the slide here for a second, but fine lettering, decorative details, sharp points, all of those things kind of are left, you know, dull, soft, whatever you want to call it. They're not as crisp as they should be in things. And what can you know relate to that, or what can not relate to, what can potentially cause that is your V-bit, you know, angles of the V-bit. That'll be one thing. We'll talk about V-bit. Wrong angle that we're using. We are using an angle that is, you know, too wide. It's causing a too shallow of a cut. That shallowness isn't giving us the detail that we need on that V carve and everything. So things kind of look, you know, dull and muddled and shallow and stuff. We can't reach that tight geometry that we're supposed to get down into. You know, we can't reach those areas and all because the bit's just too wide and the toolpath won't allow for it. We have run out, and this is something that all CNC users, very few pay attention to it, because they're not machinists, right? They're not, and that's the wrong way to say it. They are machinists, but they're not like, you know, where, oh God, I gotta, you know, every little thing makes a difference. And we don't sit there and we don't sit there and test for run out every other day or everything, you know. And what run out is wobble, right? It's when that bit is not spinning true. So I'm a country boy. I like the word waller. That's a term. That's an actual mathematical term, isn't it? Waller, when I waller out a hole. And not mathematical, but it's a term. But if I'm drilling a hole and the top of my hole is wallered out, right, I got some bit deflection happening and everything. And that deflection could be caused from, you know, going too fast on the plunge, causing the bit to flex. And then as it makes that plunge, it'll straighten itself out. So the top part of the hole gets wallered out. So run out could be inside my collet, inside your router, that cone, that conical shape where the collet goes up in, dirt, grime, grease, residue, gum, and all that buildup that's in there. If we don't clean that when we put our collets in, it could cock the collet just ever so slightly to the side, and the bit's not spinning on true center. And if you put it under a microscope, you could see instead of it spinning true, there's a little bit of a wobble. That's called run out, right? And you could actually put a dial indicator on your bit, on the edge of your bit, and you could turn your bit and you could see that dial move. And you could determine if you have any run out happening, you know, and everything. There's wonderful places online. I don't really get over to their website often. I think they still offer it, but PreciseBits.com, not Bits and Bits, PreciseBits.com. They sell collet cleaning kit and everything. They sell a cleaner. But basically you could also use a Q-tip and a degreaser and stuff. Don't ever stick your fingers up in there, but you could kind of clean up in there and get rid of all that pitch gum and resin and residue and stuff. Make sure your collets are clean, make sure they're tapped out and stuff, because even if your collet has got gummed up and all those little fins and stuff, and it can't close properly on a bit, it can cause it to cock a little bit or be too loose and slide out. All of those things, right? So run out. A non-true spinning bit. That can create issues. And then the unrelated to like crisp edges and all that stuff, but using the wrong toolpath. And this one, the reason why I threw this in is because I see this a lot. Pocket versus V-carve, okay? On a pocket cut, I'm kind of bound and restricted by the diameter of the bit that I'm using. And if I'm doing letters or graphics or anything where I need to get into tight detail and designs, and I happen to do that as a pocket cut, I don't care if I use a V-bit or not, and all I do that as a pocket cut, I'm not going to get into those detail areas and get those crisp corners where those lines come together at a sharp edge and all. And so they'll end up getting rounded off, if you will, by the tool itself, because of the nature of the tool and everything. And your letters don't look as crisp. They look a little, kind of rounded off and things. I'm a big stickler. I always say if there's text or graphics involved, then 98, I'm actually sorry, I'm going to go 99.8% of the time, you should be running a V-carve toolpath, over a pocket cut and all that stuff. But I see a lot of people, even see Vectric even taught a class in one of their tutorial videos, and one of their beginner getting started videos, their welcome sign, I think it was, or whatever it was. They did it as a pocket cut on this text and everything, and it was great. It was fine. You got to understand that you're going to get rounded edges where sometimes the text that I typed out wasn't rounded. I had nice sharp edges on my B or in my A or this that, but when I look at my results, it's rounded and all that stuff, and it's because I did it as a pocket cut instead of a V-carve cut kind of thing. So incorrect toolpath type could contribute to that. The step down, pass depth, your plunge rate is what I'm referring to. Your step down rate and everything, your plunge rate, you're coming down too fast and it's causing the bit to deflect. Okay, so if I'm drilling or if I'm just plunging into my wood, I don't care what machine it is, bits deflect. So there will be a slight deflection and everything, and that bit straightens out and stuff like that. Hell, if I'm going too fast through a material, my bit can act. The machine could be built like a rigid tank, but my bit still will deflect until it catches up to the cut and everything. That's where you get what's called chatter. That's the bit, deflecting and catching up, right? That chatter and everything. And so my feed rate, if I'm too fast, then I start, getting deflection and things. So it's not always on the plunge. It could be on the feed rate too. And that could lead to broken bits, bad cuts, rounded or washed out details, all of those things, So if your design looks great on the screen, right, in the preview and everything, but in softwoods, you have, not so great results. And I don't, calling out softwoods because that's where hardwoods, you typically get really good detail on hardwood. Softwoods is where, detail starts to lack a little bit, like your poplars. Pines, cedars, and everything. Poplar is one of those weird woods where it kind of, it's a softwood, but it kind of has the qualities of a hardwood. you know, as far as details and stuff like that. But in your softwood, you typically lose details and all. So what you can do there is basically, you know, look at your bit as the issue possibly. And it's not just, you know, the type of bit, but it could be, you know, how fast the bit's plunging, how fast it's moving, spinning, all that stuff, your bit, and then the type of toolpath, you know, for your results. And rounded or washed out isn't always an edge issue, just a result. Rounded, meaning not crisp and sharp corners. I got rounded corners because I'm using a pocket cut instead of a V-carve, that kind of thing. That's what that means, okay? And so the, you know, we want to look out for that stuff. Is this all anybody making sense? And let me hit some comments. Let's see here, because I got a lot of people, you know, chiming in here. Let me make sure that I don't have any. Good to see all you guys and girls in the chat too, by the way. I don't know if any of this is making sense or if I'm boring the hell out of you, but I'm trying to give you a verbal lesson. We're not drawing right this moment or anything like that in Vectric. And tomorrow, come on back because we're going to do some cool drawings. And by the way, ladies and gentlemen, by the way, I want a show of hands real quick, kind of just a little bit of a pause on the subject change for a second. Show of hands. How many of you have really started kind of leaning into like using AI or ChatGPT to help you create designs, help you come up with project graphics based off some of the things that we've talked about in the past and all that wonderful stuff? Because man, oh man, oh man, I want to just show you a real quick graphic that I was teaching a class, a one-on-one kind of class. And I asked ChatGPT, I said, okay, I was teaching someone how to utilize AI, right? And I said, GPT, I want you to create and there's 4 different, by the way, make a note of this mentally or verbally or write it down. There's 4 types of illustrations we use with CNC. There's an etching, keyword etching illustration, vintage illustration, woodcut illustration, line art illustration. Those are the 4 main types of carvings or types of you know, graphics you want to ask GPT for. Etching is the most detailed engraving. It's going to be longer run times and all, but the highest detail in the engraving. In your vintage, slightly under etching, still really well detailed, but a little less runtime. Woodcut is production type graphics and things like that, and then line art are going to be the less, you know, type graphics and all. But there's 4 types of graphics, those 4. And I asked GPT in this lesson that I was teaching, I said, hey, give me a vintage style illustration based off of the celebration of the 250th anniversary of the United States coming up, America coming up. Include Mount Rushmore, ships, the Liberty Bell, and an eagle, right? And I think that's all I said, really. And anyway, the result that GPT put together is on the screen right now, right?
Oh.
And dude, it is a bad, excuse my language, it is a kick butt graphic. Vintage style means the detail, you know, in the leaves and everything. That crosshatch really, you know, comes out vintage style. I love vintage style illustrations. It has the most detail in things and everything. But I didn't tell it. I didn't tell it to lay out. I just said, you know, use, you know, lay it out in a way that makes sense for the, you know, the occasion, the sign and all. And this is what GPT spit out. The customer that I was teaching that's, you know, kind of gave that graphic to them and all, he about fell out. He had no, he's like, holy shit. He had no clue that, you know, something that cool. And I really loved that design. So I just want to know how many of you are leveraging the power of AI in your designs and stuff. And we're gonna create, you know, some designs coming up and all, and some carvings and stuff, some, you know, real cool stuff. We'll get into that designing, but tonight I just want to talk about observation, visual listening, what to look for bad cuts, and how to possibly improve them and get professional results, right? So, but man, that was a cool, that happened the other day. I was like, man, that's nice. All right. So, let's talk about inconsistent depths of cut, right? Now, the inconsistent depths of cut can relate to I'm doing a pocket cut, and I was supposed to carve a 1/4 inch deep pocket, but hell, that thing is more like an 1/8, 3/16, or heck, that's about 3/8 of an inch deep a cut. You know, it could be going too deep, too less, right? We could, while we're carving and stuff, we could be carving, and literally the depth of cut should stay somewhat consistent, but it varies a little bit and everything. So, some of the key results, and this I'll talk based off of experience and everything. Let's say that I am supposed to do a 1/4 inch deep pocket, but I go to carve this thing, and man, it's a little bit deeper than a 1/4 of an inch. It's more like 0.3, 0.375, and it's like it's really it's going way deeper than it's supposed to. Typically, what you're going to see there is there's two kind of real main causes. One is I've zeroed out my Z incorrectly, or I zeroed out my Z correctly, and when I raise the Z up, I may be on a machine that doesn't have limit switches that stops me, right? And so if I don't have limit switches that stop me and everything, and I raise up and I hit my Z positive limit, not realizing it, I'm going to put my dust brush on, or I'm putting my dust skirt on, whatever the case may be, my dust shoe, and I raise up, not realizing I hit my limit, and the machine makes a sound, what have you, and I don't pay any attention to it, and then I start cutting. Well, it's lost its steps. It now thinks it's higher than what it actually really is, and so it's cutting. And I said deeper earlier that result would cause a shallower cut. So if I was supposed to be cutting a 1/4 and I'm cutting a 1/4 and I'm cutting 3/16 or something, the machine thinks it's higher than what it is, and I just screwed myself up. That's a lie. It's deeper cut because the machine hasn't moved. It thinks it's higher than what it is. So when it drives itself down to that negative 0.25 inches, it's actually deeper by the amount that it lost up there. I was getting myself screwed up. See there? Not everybody gets everything right the first time around. So I raise up, hit my limit, not realizing it, go to hit start, and all of a sudden the bit is going down deeper and carving more than it's going to do it in a couple of passes, but it's carving deeper than it actually should be carving and stuff. Another thing is that I don't maybe I'm using a touch plate or a touch puck or something, and I don't quite have it set flat correctly, or I might not have the thickness programmed incorrectly, and I go to touch off and I'm off. Or if there's any deviation in my board, twist, cup, crown, curve, whatever you want to call it, I might be carving shallower here and deeper here and everything, because my Z0 is not consistent all the way across the surface. All of these things could relate to an inconsistent carving depth and everything. So twist, cups, crowns, not having a properly flattened spoil board, and all of our materials are referencing off of a surface that's not quite parallel to the travel of our router. We don't have a perfectly parallel plane. We could be clamping something, and we could have introduced some kind of unevenness in our situation, whatever it may be. And then again, zeroing out the Z. So all of those things can lead to inconsistent depth of cut. And they typically, that it's literally, a lot of times it's in the setup and stuff. I have had on machines that may not have been as rigid or construction wise and everything in its build and all, that a dust brush that the bristles don't flex well, those very stiff bristles on a dust brush, where when it's going down to cut, the brush literally the bristles aren't flexing, but the machine, the rigidity it is, and it's causing the depth to get lost. So the bit's not able to go down as deep as it's supposed to. And then as that turns a corner, the bristles do flex and the bit can get down. So all of a sudden, you got a nice little swerve down where it's like, why is it shallow here? And then it just ramps down, or deep here, and it's all inconsistent. And it takes forever to figure out that one when you're like, man, what's going on here? And then you realize what's actually causing it and stuff. And, all those things kind of can relate to inconsistent depth cuts and stuff like that. So, what we want to, be mindful of is like in V-carve, I don't care if you're using 120 degree V-bit, 22 degree V-bit, 90, 60, whatever, your carving will look the same as far as visually, but the depth of cut varies based on the angle of the bit you're using. So when you go from a 22 to a 60 to 90, when you ask yourself, why am I using all these different bits? Why do I want a 60? Why do I want a 22? Why do I want this? It's not going to change the way the design looks. It's going to change the depth of cut. So we go to these different bits to get more depth and detail in a carve with a narrower bit than we do with a wider bit and things like that. But if we're doing, carving and we're getting, inconsistency, like, man, it's not, we're not, that cut was supposed to at least cut, 20 thousandths of an inch, but it barely scratched the wood. It's because the wide angle bit isn't really carving that deep. And on top of that, if I have any kind of inconsistency in my surface, my zero is not consistent all the way across, that contributes to depth of cut too, right? So we want to look out for those stuff. So your CNC, and I'm going to just read this one kind of verbatim and all, it has no idea that your wood is whacked, right? It's that it's warped, cupped, crowned, uneven. It has no idea that your CNC machine's wasteboard isn't surfaced. It has no idea that there was a bunch of debris on the table that didn't get vacuumed up when you put your board down, and it caused a little bit of a hitch in one of the edges, or whatever the case may be. It has no clue, right? All it's going to do is follow its programming. It has no idea that when you raised up the brush and hit your limit, it doesn't know that that was a bad thing, right? All it's going to do is look at the G code and follow the instructions on the G code. And if the settings are wrong, because now I'm lost my Z position or whatever the case may be, and I'm told that in my G code to go down to negative 0.125, and I'm going to go down to negative 0.125 because I think, that's what I need to do, but actually my Z was wrong. The CNC doesn't know that. Right? It's going to follow those instructions exactly how it's programmed. Faithfully, obediently. It's going to do exactly what it's told to do. So if there's any kind of inconsistency or any kind of error in the setup or any kind of issue that got introduced, then we're going to see those results. Okay, and those inconsistencies. So make sure our spoil boards are surfaced properly. Make sure our work holding is, we're holding things down flat. If there's a curve or a crown, try your best to not carve on those type of woods. But you can also surface your material before you cut it, if there's room for that. If you've got margin for a little bit of material to be milled off to flatten it out, you can always run a surface cut before your carve cuts and things like that. But those are the things that we look for with inconsistent depths, those kind of issues. Agreed? Agreed. All right, cool. All right. So with that, let's get into a little bit like burning, burning and stuff. We kind of touched on that a little bit a while ago. Rubbing, bit moving too slow, spinning too fast causes rubbing. Rubbing builds up heat. It's like friction. It's like a friction fire. One of those, prehistoric. Not prehistoric, but like you're out roughing it in the country and you're kind of got a stick and string, and you're rubbing those two pieces of wood together to cause a fire, right? We're burning our wood and stuff. So when you have scorched edges, hot spots, all of those things, what we want to look for is what are our friction points? What's happening to cause friction? Because friction It's pure friction. Okay, so when the bit's dwelling too long in one place, meaning it's too shallow of a cut, we're just kind of hitting the same place over and over again. Our pass steps are set to, too fine a steps, so it's, again, we're just kind of concentrating too heavily in an area. We're building up heat, we're using the wrong type of bit, a down cut instead of an up cut, and chips aren't flying away, throwing that heat away and everything. We're causing friction and stuff. And so, and we're going too slow, that's all going to cause heat, friction, burning. And so dull bits with sharp edges causes burning, chip recutting causes burning. So again, that's that. If I'm using a down cut bit, let's say in hardwood or something, and who's to say we can't use a down cut bit in hardwood, but if I'm doing shallow channel cuts where there's no real opening, that's going to happen to kind of give a little bit of relief. If I'm doing a profile cut and I'm using a down cut spiral bit and all that, I'm recutting those chips. Those chips are getting packed in to my cut, and my bit is having to not only cut the wood, but it's having to recut the chips, and it's going to cause it to heat up. And when it heats up, it's going to cause burning. So recutting, right, in enclosed type areas, pocket areas and all, where we don't have an opening where things can kind of fall out or blow away, or our vacuum is not extracting it well. Our dust collection and everything, right? So one of the things that we can do is, pause the job, clean it out, vacuum it out, whatever the case may be. A job that I just did recently, and I posted on Facebook and all for my grandson, a sign and everything that was cutting, and I was cutting cedar. And I was treating the cedar like plywood. I was using a down cut bit because the profile and the things, the holes that were getting cut for this sign that was going to hang over the crib, cedar is prone, it's very soft, prone to chipping and tearing out and stuff like that. So I wanted to use a down cut bit. And on my down cut bit, I definitely didn't want to burn the cedar. I didn't want to have to do any real detailed sanding to get burn marks out and all that stuff. So I would carve, and it was carving a big profile and everything. And so as it made its pass, when it started making the second run, I was chasing it with a vacuum. That I was cleaning out the path. In the vacuum, I was tired of listening to the vacuum. Then I broke out an air hose. I'm like, I'll clean the shop afterwards. Broke out an air hose and an air nozzle, and I'm blowing out that channel and everything, as that cut is happening and stuff. So the bit is not having to recut the chips, right? And all that stuff. Whatever we got to do to make it happen. But recutting of chips is a cause of burning too. So friction, anything that can cause friction. So dull edges on our bit, slow feed rate, repeatable, we're just repeating in the same area over and over again, rubbing, all that stuff. So never pause the running cut while the spindle's on, right? Because you end up burning a hole, right? In especially plastics and stuff like that. So in my case, I didn't pause. I chased, basically, with a vacuum or a blower. I had blower. The vacuum was a little while, it was okay, but then I got tired of listening to the shop vac. So I turned to the air blower, blowing it out, following that chase. And also burning, that's how we can kind of keep anything, just prevent friction and stuff. All right. We're trying to get through this. We're not, I'm not going to, go, I'm going to kind of breeze past a lot of stuff. But one of the things that we always deal with is witness marks or pass step marks, or what you consider also tool marks on our cuts on the outside edges and inside of pockets, and even on the inside of the bottom of a pocket and stuff, we can get tool marks and stuff. And that's where we typically spend a lot of our tedious time sanding and kind of cleaning up those edges and all. So one of the things that we can do is always add some type of finishing cut, finishing pass to our cuts, whether it be an edge cut, an inside cut, or a pocket cut and everything. So lot of times if we are carving a pocket cut and we got, tool marks in the bottom of the pocket or on the edges and stuff like that, then if we maybe set up a final pass cut that where the bit has no strain on it, no friction against it, none of that stuff, it can just do its job and clean up a final pass, that's going to clean up our results dramatically. And that's on the outside edge and the inside edge as well. So the profile cut has the toolpath in Vectric has a last pass option built into it. You can literally check the box, do last pass. You can set the distance, how far you want that last pass to take, or how much way. And what happens is in all the previous passes, it steps away from that line and at whatever number you set, and it makes all the cuts. And on the very last pass, it then moves up to the line and takes the full cut, on that profile cut. And that eliminates a lot of the witness marks or the pass depth marks or the lines, whatever you want to call them. It eliminates all that and kind of creates a clean pass. Well, on the bottom cut of a pocket, if I have a pocket that I'm cutting that is, let's say, 0.25 inches deep, I'm most likely going to set a cut that is cutting 0.23 or 0.24 inches deep. And then I'm going to do, and however many passes it takes to clean out that pocket, my normal passes for the tool and all. But then I'm going to create a second finishing tool path that's going to do one pass all the way to the proper depth of cut, 0.25. And at that point, when it's doing that, there's no friction, there's no deflection, there's no nothing on that bit to cause it to, leave. It can only, its only job at that point is just to focus on that little bitty 20 thousandths of an inch that's left over, 10 thousandths of an inch that's left over. And, we're going to clean up that pocket. And we can do the same thing on the inside profile cut too. We can have two vectors, one that does our pocket, to our 0.23 inches deep, right? Whatever the case may be. And then on that vector, it might be 10 thousandths of an inch smaller. We have another vector on the outside, and we're running that pocket. And then our next pass can do one pass on that outside line. So it's going to carve that 10 thousandths of an inch right to the line on the edges, but it's also going to carve to that 0.25, that full depth in one pass. And so it's going to clean up the edges and the pocket depth at the same time. It's a finishing pass, right? So one of the things that what we're looking for is, let me just read this off, visible parallel ridges or scallops or, rough, bottom cuts and things like that on the pocket floor of our pockets. Those line marks on the inside and outside edges on a profile cut and things like that. Those things really stand out. Like I said in here, when you're painting or staining, it's like you can really see, that those have really come out and all that stuff. We have to do a lot of sanding to clean them up. Well, one of the things that causes this to happen is if our step over is too large, right, on our bit, typically like an end mill, we're stepping over 40% of the bit. On a ball nose, on a 3D cut, we're stepping over 8% of that bit, right? But if our step over is too large, we're kind of almost like jumping over little areas and we're leaving little areas behind, and it's kind of creating uneven cuts, or we're not getting that smooth finish and things like that. And so the every adjacent pass kind of is overlapping itself enough and causing that imperfection, if you will. This is where the correct step over helps correct that. On the finish pass, right, if we don't have a finish pass and everything, then literally every first cut, my first V carve, my first pocket cut, my first profile cut, I consider that it's a rough cut. It's a rough cut. It really is. You have rough cuts and you have finish cuts, right? So not just with 3D models, with carving too. So your rough cut is the one that does all the major work, gets everything, all the junk out of the way and gets everything cut and everything. Your finishing cut is what comes back and does the final carve detail to full depth, one pass, nice carve detail where the bit has no work to do. There's no chips in the way of it and everything, and it can just do a clean cut. And that's if you're V carving, pocket cutting, profile cutting, whatever the case may be, right? So one, if I introduce a finish cut into all my tool paths, that's going to make me run longer, and it's just going to make the job longer and all that stuff. No, not really, because of the simple fact that it's doing it one pass, cleaning up. We're not, it's going to be a quicker cut and all that stuff. And that extra cut, that extra finish pass helps reduce whatever sanding we have to do to clean up those lines and edges anyway. So trust me when I say it balances out more so than you would think. And there's no balance. More time on the machine wins every single time over labor having to clean it up after the fact. Wins every time. So that adding a pass step is not a negative by any means in your carvings, in your systems that you set up for yourself. Okay. And then again, wrong end mill geometry and stuff like that. Now, many times I've seen someone, like the other day I saw it, and it kind of led to this and all. Pocket cut or a pocket cut, right? A clear out cut or what have you. Typically where we would use a flat bottom bit to get a nice clean finish and all, using a ball nose bit. A ball nose bit only carves on the tip of that ball. That bit is curved. And so when it's down at the depth of cut, it's only that depth of cut is only concentrating right here. And then if my step over is too great, using the ball nose bit as a pocket cutting tool or something like that, and it was on like the ball nose bit. It was a pocket area, but it was on a molding tool path. They were doing a molding and a tool path and everything, and they had the finish. Sorry, they had the rough part of the molding tool path, the rough cut or the clearing cut. That's what I was looking for. They had it set as a ball nose and everything, and not realizing, flat bottom bit. We want a flat bottom bit in our pockets and things like that. Now, they were like, well, I'm just using a ball nose because I want that nice rounded edges. And I'm like, okay, that's a radius end mill, right? You're wanting a bowl and tray cut, or you're wanting that type of cut, or whatever the case may be, but that's a radius end mill. It's flat on the bottom and the edges are radius. So when it is cutting up against that edge, it's giving you that round transition that you're looking for. But also in the field, the flatness of the bit is carving that pocket, right? Now, I like using an end mill and then using the finishing bit being, a finishing bit being my my bowl and tray. I don't mind the tool change and all, but, someone does the whole rough and the finish and all with their bowl and tray. That's fine too, because it's a flat bit with those radius edges. It gives you that radius transition. But a ball nose, no, a ball nose is not a bowl and tray, but a ball nose is round. And so it's only really focusing on the tip and everything. So that can cause inconsistencies in the bottom of your pockets and things like that, right? So somehow or another, whether it be the bit heating up slightly or just an inconsistency, even a little deflection, even a little run out, right? It's always going to leave some kind of physical, I call them witness marks, right? Witness that it's been there, right? It's always going to leave some kind of that. And so adding a finishing pass to your cuts, in my opinion, when I'm teaching setting up systems, it is a good thing. It's a good thing. There's no negative about it. It's going to produce a cleaner finished result. Less work for me to do after the wax. So and I say it here, without a dedicated finish pass or a tighter step over or lighter depth and all, those ridges are going to be permanent, right? They're going to be in there unless you sand them out, kind of thing and stuff. So think about that. Think about that a little bit. Look at your tool paths, even on V carves and stuff like that, and things and all. What we can, do to maybe do a cleanup cut and all that stuff and everything. All right. I think I'm beating the dead horse here, but I've got on the problems and all, and let me kind of go through here. on the 7 problems, I kind of went 7 problems, but basically this last one is the same that we talked about, chipped out, and it doesn't matter if it's on letters or fine detail, right? So chipping, tear out, all of those things. It has to do with, grain direction, in the cut. It has to do with, you're being aggressive on your depth of pass. We've said this in past slides a moment ago. V-bit angle mismatch and dullness of the bit, right? I don't want to have to repeat all that over, but those factors that cause fuzziness, that cause burning, that causes chip out and tear out and all that, doesn't matter if it's chipping on letters or detail and all that stuff, or if it's a pocket cut or if it's 3D model cut, it's all the same. They're all the same relative problems and everything. Now, let's we've talked about the causes, right? The tooling mistakes, and we've talked about using the wrong type of tool or the dull tools and things like that. And so one of the things that we do is one of the things that we make a mistake of is we might have a dedicated bit that we use for everything. We have a 1/4-inch bit that's at our machine right now, that if I'm doing a pocket or I'm doing a profile cut or I'm doing a 3D rough cut or whatever, that's the bit that's going to go into my tool, right? And everything. And so what we want to make sure of is, if we're not keeping that, an eye on that bit, it's cleanliness. Like if we're not cleaning our bits regularly, if we're not removing any pitch, resin, gum buildup, or if we're using it for everything, that bit, they dull. On any of our cuts, we're always generating heat in some way or another. There's going to be heat that's generated at some point in time, and heat is what dulls a router bit, right? And materials and woods that we cut in, and plywoods with all the layers of veneers of glue and wood, all that glue, all those different types of materials, they dull bits, they chip edges and things like that. So that go-to bit, we can go to a 1/4-inch end mill every single time, but the same bit over and over again for weeks on end, months on end, days on end, whatever. We want to check the life, of that bit and how it's doing, how's its edges and all, and how are our cuts looking. They used to look great, man. Oh my God, I did this pocket cut and they were beautiful when I come off, but now they're a little lackluster, coming off the table. Well, I'm going to absolutely look at the bit and, maybe it's time to change it. I'm not a big advocate of sharpening bits and tools and stuff like that, but, if you have that tool, that 60-degree 1/4-inch V-bit, white side 1541 that you use for every job that you do, they don't last as long as you want them to if you're building up a lot of heat over many projects and all. So change them out every once in a while, because that can, dull bits and are good go-to bits and all. They work hard, and they also, the results, they get damaged, okay, and stuff. So like all of those things. So let's talk really quickly about our feed and speed, okay? The most misunderstood setting. And I'm not a feed and speed expert by any means, but too slow of a feed rate leads to burning and fuzziness, right? We're rubbing, heat, friction, and also we're not taking chips proper, and all that can lead to that. So the bit rubs instead of cuts, friction builds up, causing heat, all that wonderful stuff. It's just a reiteration of what I just talked about. The sweet spot, right? Clean cuts, chip load in range, within a proper range and everything. We get nice severing of our fibers, nice shearing of our cuts, clean evacuated chips flying out. The bit runs cool, and this is where, that's our sweet spot. So feeds and speeds, we got to find that sweet spot. And there's no magic number. There's no magic calculator out there. There's calculators out there. Yes, they'll get you close and everything. But in different woods, they react different. They act differently. Different materials, and doesn't have to always be wood, but different materials and all, they react and act differently, to the situation and all. Our ears will pick up issues before our eyes see anything, and before we can react and stuff, our ears have already alerted us, right? So we can use our calculators. We can use our speed and feed, charts online and all that stuff to get us close. But the only way we're really going to master speeds and feeds is observing cuts and testing, our machine, and, testing cuts on different materials and different bits, making notes, and then going back and, adjusting, feed rates and RPMs and all that stuff, plunge rates, and making notes and going back and setting up our tool database properly. And for those of you, and I'll say this, and Garrett, if you're ever watching, hopefully don't get offended, but go back and fix some things. But like IDC Woodcraft, right? Great tools, beautiful tools, love them. People download their tool database. Same thing with a Mana, if you're watching. No offense to you either. They download their tool database and they load their tool database. They load IDC's tool database and everything. And the settings on the tools are wrong. Absolutely wrong. Do a V-carve cut with any one of IDC's tool settings on their V-bits and everything, and that cut is going to run for hours when it should run for minutes, and you're like, what the heck is going on here? And they have the pass depth at 0.05 for the V-bit when it should be 0.2 inches per pass. And also it's taking these light passes, which end up resultantly burning the wood, causing all these issues and everything. Wrong. But I downloaded it from their website and everything. No, yes, you downloaded a beautiful database from their website that has all their tools, makes it convenient and everything. But the settings, 100% wrong. Some of them might be close, but when it comes to the V-bits and all that, they're wrong. So Garrett, if you're listening, fix that, man. Anyway, I have to do a lot of fixing on those when people buy your bits and all. And I love you to death. I love your tools. Don't get me wrong. But man, people trust things. Don't trust. Trust your ears, trust your eyes, trust your machine, what you're seeing right there in front of you. Not what some calculator is telling you, not what some tool database is telling you, not what some expert is telling you, right? I like to think of myself as an expert, but I'm not an expert in everything, right? So don't trust what I'm saying. Trust what you're seeing and make the adjustments accordingly. And you just need to know how to make those adjustments. So whining, burning, fuzziness, things like that, you're going too slow. Increase your feed rate. Maybe slow down your RPMs, okay? If you're getting rough edges or tear out or chip out or chatter and things, or you're breaking bits, or you're pushing your material right from under your clamps, you're going too fast. Feed rate's too fast. Slow it down. RPM is too slow. Speed it up. Don't do both of them at the same time, one or the other. Figure out what the cause was and then make the adjustment accordingly and everything. So there's two sides of that spectrum, and they're big sides. There's no fine point, but somewhere right in the middle is that proper setting, And no tool database that you download from Digital Woodcarver, from a Mana, from IDC, or any of that stuff is going to be 100% correct. It's going to give you all their tools. It's going to give you some settings that might work, but they're not going to be 100% correct. Only you can fine-tune your settings to your situation and all to correct your tool database to give you the cuts, the results that you want. All right. I'm gonna have. Don't be mad at me, Garrett. Now, and I'm not knocking you. I'm saying you have wonderful stuff, but your tool database isn't 100% correct. And it could be, if you had someone there that could test your machines 24 hours a day and just take notes and blah 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 blah, and go in and change your tool database and all that. And nobody has that kind of employee time or any of that stuff in any kind of situation. But maybe we could hire a guy that just that's all they do. All right. Anyhow. Try not to force your cuts. When I mean force cuts, don't try not to be. I know everybody. Look, I'm going to get this done. I'm going to go in 2 passes. I can knock it out and all that stuff. If you're trying to get production and you don't care about the quality coming off, and hey, I've got other machines that'll fix that edge or do that and all, fine. Whatever you got to do, you do. But if you only have your CNC machine and your employer or whatever yourself, and you got to get products that good quality off, less handling time, that you can get this out at a reasonable price and all. Try to adjust your pass steps accordingly. Don't be too shallow. Don't be too aggressive. And normally half the diameter of the tool bit or less is your rule of thumb for pass depth, but it can vary, or less, right? It can vary, but not too less, not too little. Too little is not a good thing. Too many passes is not always a good thing. Too little passes is not always a good thing, okay? So try to introduce a finish cut, a finish pass into your cuts. Whether it be drawing an extra vector that's, you got your main vector that's the right size of the pocket, but then you have another one that's 10,000ths of an inch in or something like it, 20 thousandths, whatever, in, and that's what you do your main cut on, down to a cut depth of 0.23, and then the next toolpath you make uses the outside line, doing one pass all the way to the 0.25, so it's taking that 20 thousandths of an inch in the final, the depth of cut and the edges, that finish cut, right? The bit's not having to work as hard. It's not having to stress. It's going to, really help increase your cuts and all. So don't think of it as a negative, like, oh God, there's just another toolpath I got to create. Think of it as a positive, something to help improve your results and all. It's a good thing. It's not a bad thing. So really think about introducing finish passes into your toolpaths and your setups and stuff. And then step over, right? Your end mills, 40% step over is generally what we are. Too tight of a step over is not always a good thing, and it's not always a bad thing, but 40%, we're typically at 40% of the step over the bit. We don't really want to be at 50%, even though I have 40 to 50% in the range there. We really don't want to be at 50% because that can kind of, for every pass, the middle of the bit, some bits have a little V in the middle of them, like end mills and stuff like that. And if we're stepping over half the diameter bit, we can kind of, with that little bitty thing, can leave a little fuzz, a little fuzzy line at the bottom of the cut or whatever it may be on that pocket and stuff because of that step over. So 40%, make sure that we step over and it cuts away that line, right? So I like a 40% on end mills. I like an 8%, no more than 10% on tapered ball nose and ball nose bits. And on your V bits, I prefer like a 3%, 3 to 4% step over on the step over, and 15% on the clearance pass step over option on. I like that step over, but I've seen people that use the V bit as a clearing tool. They're not using an end mill. They're just using the V-bit to do the flat area clearance area too, because it might be a small area or whatever. You would actually want your step over, the clearance step over, to be tighter than 15%, so you get better results and you don't see those little V lines in the bottom of the pocket, and stuff like that and everything. So you might have to adjust that, not in your tool database, but in the edit button in your software. When you calculate your toolpath, that edit button to edit the tool, it edits and changes the tool settings for that toolpath only. It doesn't overwrite your master settings and all, but you might want to, if you're using the V-bit in a V-carve cut and you're not using an end mill for the clearance, you're just going to let the V-bit do the flat work, then you definitely want the clearance toolpath to be tighter, a lower number, because it's acting as a clearance tool. Vectric will treat it as a clearance tool if it's clearing out an area. It treats it as a V-cut, your normal step over, that step over. That's your V cut when it's used as a V cut. But when the bit is used as a clearance tool to clear out flat areas, then it's using the number from the clearance step over. So you might have to reduce that number to get a tighter step over for that clearance cut to be nice and clean too. Right? So those things. But try not to force the cut, okay? And things. And I'm not saying every graphic and every text is a V-carve cut over a pocket, but yes, it is. So the rule I like my rule, and it's not always the right rule. I'm not the for be it the authority on all this, but typically when we have text with nice, clean, sharp lines and things, or we have graphics with nice, clean, sharp details, we want to use a V-carve toolpath over a pocket toolpath for that design. It's going to give us those nice, crisp details that we need, not rounded off based on the radius of the router bit, right? And how far the bit can fit and all that stuff, okay? So the last thing I want to kind of touch on really quickly is we've been talking about climb and conventional and everything. I want to kind of just really quick touch on that, and just so you kind of understand what's what, okay? So conventional carving, the bit, hold on, I'm about to choke. Give me a second. I You ever gotten where you can't swallow? And you feel like, oh my God, why can't I swallow? It's like you forgot for a minute, my brain. The bit is cutting against the direction of the feed rate or of the movement, direction of the cut. So the way the bit's feeding, basically, it's cutting against that. And so the what it's doing when it does that is it's starting on your chips. It's taking the thinner chip. Okay, it starts thin and it gets thicker as it comes out and everything. And so it's not really in woodworking and other things, it's not really the best way to go. Now in metal milling, we kind of want a conventional cut because we too want to take the thinner chip to the thicker part. We want to kind of shear into it, right? And things like that. So we typically see conventional carving in metal work and stuff like that. We'll see that we generally see that more being used in metal milling than we do in other cuts and everything. So one, we'll say this because it is taking a thinner cut, to the thicker chip. It is a more stable cut. That's why it's great for metal milling and all that stuff. It is less prone to tear out on leading edges and everything. And it is a good tool path that you could use with profile cutting and all because of that, and not in edge cutting. So inside pockets and things like that. So if I were doing a climb cut in my pocket, and on my last cut all the way around on that edge cut and everything, I could change the cut direction to a conventional cut, and on that last pass and everything, and I could reverse the cut direction is what it's referred to in, I think the profile toolpath says reverse direction on that. I think it refers to reverse the direction on the final pass option that you check off and everything. And so what that means is, I'm climbing, but on that last pass, do it as a conventional, right? Because it does, again, it's taking the thin chip to the thicker part, as it comes in. So it's kind of a easier cut on it and all. But the problem with that is it is going to be a less desired result in a lot of cases on the cuts. It is safer for most CNCs. It's a better edge quality. So, on profiles and inside pockets and stuff, but you do get more heat buildup and more wear and tear, shorten your life expectancy and all those things. Now, but that's just those edge cuts and things. And it's because it's just less aggressive and all that. So for a finish pass, yeah, you could go conventional, or in your metal milling conventional. But everything else, we want to kind of go climb. And so a climb cut, the bit is cutting with the direction of the feed. The chip starts out thick, so it's taking the bigger part of the chip and it's shearing to the thinner part and throwing it away. And so when it exits the wood, it's starting thick, so it's an aggressive cut, thins out as it's coming around, ejects that chip out, right? So it produces a cleaner finish, right? Cleaner surface, but it requires a little bit more rigid CNC, backlash free, machine to avoid chattering and pulling and all that stuff. And most of our CNCs can handle it and all. That's why we do it and everything. So your climb cut, and it produces a cleaner finish result, less heat buildup, longer life expectancy on the bit, less heat buildup. There are some risks with it, that grabbing, so if you do have any deflection, or if you do have any little non-rigidity in your machine or anything like that, it can grab. That's what chatter is, it grabbing, and stuff. And it can cause that. And it is definitely not recommended for those aggressive cutters out there in the world that are taking full pass steps and all. You do kind of want to lean over to the conventional cuts for that and stuff. But Climb cut is going to do typically better edge, cleaner finishes, less wear and tear, and less heat buildup on the bit, and generally, overall better results for general CNC milling. Again, Climb cuts with the direction of the feed, conventional cuts against the direction of the feed. All right, and all that wonderful jazz. So I don't know if they're like, dude, I think you just confused us more than you helped us on that one. For most hobbyists and small CNC machine setups, right? I have this note here, but conventional milling is kind of a safer default, right? Because it's the bit is taking less of the cut and it's not being aggressive and all. But with every give, there's a take. So your finish and all edge results and your finish results and your heat buildup and your bit replacement and all that, will sacrifice and all that. But the Climb cut is going to be typically your default. But in the case of machines with not a strong rigidity, use the Climb cut as your finish, right? For your lighter finishes passes and stuff like that, rather than your main run. So I would say, I don't think there's any, unless it's like a hobby DIY plywood machine or something like that you put together and all that stuff, you're going to be safe. You'll be safe sticking with a Climb cut for all your cuts. Conventional cut for surfacing cuts. Conventional cut would be good for edge cuts, finish pass edge cuts. So that last pass kind of situation, metal milling and things like that. Other than that, you're going to use your default. Now, if your machine is really not that rigid and all that stuff, then stick with Climb and stick with conventional and use the Climb cut as your finishing. So reverse that thought, that training, But for all of us, I think most of us, whether we have X-carve Shipokos and things like that, most of our machines, 150s and all that stuff, most of our machines are fairly rigid. So Climb cut is a good way to go. But test your machine. This is what testing comes into play. Test your cuts. Do a cut in a Climb cut. Do the same cut on the same piece of wood as a conventional cut, right? See which one produces the better results for you for your situation, right? Test. Okay, let's wrap this up. And I don't want to get all in. I made this. No, Alexa, I don't need you to help me wrap up. Hold on. I'm going to make this PowerPoint presentation. Alexa, you can help by hush, be quiet. Okay, please. Okay. Thank you. Sorry, AI. I'm going to make this slide PDF printout available for download, and I'll put it in the link in the description for you guys to go through. There's a lot that I wanted to be able to cover, and I will cover in another class, but we're going to kind of stop here today because the rest of this has to go. It goes into depth of we're going to be talking about machine setup, workflow, and creating professional systems to help with the cuts, choosing the right bit, all the things that we've talked about. This is just a reiteration and all, but I'm going to have another class where we have kind of a part 2 of this. I don't want to go any more than this. Our brains are already taxed, but we're going to have a part 2 of this where we kind of go into these things because I want to really hit home with this. This little bit of information, and I'll make it available for you to print out, download and print out and read on your own in a while too. But this information here, and I'll make the whole thing available to you. But this is where our answers lie on, what can we do? What do we look for? What do we change? Where do we start, to get better results and things? And all of the things that we just talked about, if you observe, you listen to your machine and you watch your cuts and you change feed rate, plunge rate, cut direction, whatever the case may be, check your bits, clean your bits regularly, check your setup and your clamping and make sure your boards aren't warped. Make sure your wasteboard is surfaced. Oil your machine, you know, and lubricate it so it's not rigidly on the bearings and all these things, your setup, your tools, your tool path operations and things like that. All of these things contribute to that more so than the machine, right? It's our setup that falls in there. So the machine's going to do what it's told to do. We just have to set it up right. And I'm hoping I gave you enough tonight to know what to look for and maybe make some adjustments. As we progress in the next course and all, we'll just kind of reiterate that, but with a little bit more tool specific, machine specific stuff, informational. So we're going to stop at we're going to stop here. We're going to stop here. I want wood direction and all that stuff. Let's really quickly, let me see here. Do I want to pass this on to you? Okay, just really quickly. So this is important. When we're carving, whether it be V carving, text cutting, pocket cutting, whatever the case may be, grain and your wood plays a role, as well as not just the bit and not just the tool path and not just the pass depth and the feed rate and all that stuff. The wood, your material plays a role as well, right? So in this situation, what this slide was saying is that our grain direction and how we cut along that grain or against that grain plays a role. So cutting with the grain, our fibers are supported. When we cut with the grain, our fibers are supported as the bit passes through, right? So when I'm cutting with the grain, that's why when we do pocket cuts, we do V-carve clearing cuts and all of that stuff. When we do 3D finish and rough cuts, we carve with the direct. I like a raster cut, not that offset cut around and around. We're going with the grain against the grain, with the grain against the grain. Oh, it's a nightmare to clean up. Raster cut back and forth with the grain. All right, it's going to give us a cleaner cut, less sanding and stuff we have to do and all that stuff. So we want to cut with the grain because it is going to produce a cleaner cut. It is going to produce minimum tear out and a better finish. Cutting with the grain. I love a raster cut with the direction of grain, whether it be 90 degrees or 0 degrees, depending on which way the grain is running on the board. Now, when we're cutting against the grain, then there again, our fibers are not supported as we're cutting, like when we're cutting with the grain, where the fibers aren't supported. We're cutting against them. So when we cut against them, now we have the tendency that when the bit is exiting the cut or as it's cutting along, that's where we have a tendency for tear out, causing fuzzies and things, chip out, tear. I just said tear out, chip out, and things. And that's where the when we're cutting against grain, that's where we're going to see all those. Like we're going to see a lot of those imperfections. We're going to see those imperfections where we run our fingernail along the cut, we get hang up and everything. Typically when we're cutting against the grain, because we're literally shearing against the grain, that natural grain of the wood. And then cross grain. This is kind of a I don't want to say a diagonal cut, but we're kind of cutting a little bit with the grain and against the grain, right? Kind of cross grain, if you will. You're going to have on this your thin letters, your sharp details that go across the grain that in your design that kind of like an A, right? Like a letter A or something that goes kind of across grain and angles and stuff like that. Those kind of cross grain cuts are going to be more prone to your chipping, your tear out, or fuzzies and things like that. So you'll see when you're looking at your cuts and stuff, you could generally look at the direction of the grain on your wood, and you can see where some areas came out really clean, some are a little bit fuzzy and chipped, or a little tear out or whatever, rough edges and all that stuff. And you can see like how the grain played a role in that cut. And there's a beautiful video that's 12 seconds long. It is on YouTube, and it's comparing a straight bit, straight bit, upcut spiral, downcut spiral, compression cut bit at like 15,000 frames per second. The guy, I forget who did it. Oh God, he did such a great job. Anyway, if you Google upcut versus downcut, right? Just Google that, or not Google, but YouTube search that upcut versus downcut bits. One of the first search results is this, upcut, downcut, compression cut at never seen before, at, I think it's like 19,000 frames per second or something. Great video, super close ups. You can watch the bits going through and you can see what's happening to the wood and everything. And you'll see in the video that the wood is actually bouncing, literally bouncing, even though it's clamped on all four edges and all. Where that cut's happening, there's nothing there holding that wood right there where that bit just cut through. And so as it's cutting, the wood is literally bouncing, causing, issues and things and stuff. So great video to watch. We're going to cut it off here, ladies and gentlemen. And I hope you got something out of tonight. We're going to continue this at another time, but we're also going to kind of we're going to get into making some cool projects and stuff too, and we'll kind of implement it all together in an upcoming class. And then tomorrow night, join me tomorrow night. I do have a live event tomorrow night, and we're going to just do a kick butt project, design and for the public and stuff. But hopefully you got something out of the night. And we'll see there. So for the end of class, ever used or seen a spindle collet nut impeller to help keep the chips clean and the bit cool? So what, JR, let me just put that up on the screen there, JR. Right here. What JR is talking about is there is on the collet, there is an impeller that acts like a fan, if you will. And when it's cutting all that, that impeller is spinning as well, creating kind of a fan effect, if you will. So it's blowing away the debris and the dirt, the chips. It's also keeping things cool as well. And let me see if I can pull one up online. You rarely see those in use and everything. They have their purposes. They exist for a reason. Let's see here. It's going to be called a chip clearing. Chip clearing. Let's see here. It is a chip fan. And, well, that one doesn't. It does. Let me see here real quick if I can. Images. And so there's a few different kind, but what one, a chip fan is something that goes on, and the blades open up as it spins, and it kind of blows off they use that to blow off the chips and everything, blow things away. It doesn't cut at the same time. So that's a chip fan and all. But then there's also let me see if I can see one on here. Let me see here. Impeller for CNC carving. See if I can be specific on that. There is a
tri-collet nut.
CNC collet nut. Let me see here. Yeah. So, and those are 3D printed items. It's a 3D printed item, but I don't know. There probably is, they call it a chip fan and all, but that's a 3D printed item. Cool deal. But anyway, they put it on the nut, and what it's doing is, as it's carving and all, it's acting like a fan and it's an impeller. And as long as it's balanced well, right, and it doesn't cause any, as long as there's a good balance to it, and it doesn't cause any run out or anything or any kind of that, then I can't see why that wouldn't be a pretty nifty little thing. I don't know if there's any market available or and all. I think they're 3D printed, and there might be files for them, but I don't know. There may be something there on eBay. There's a couple on eBay kind of thing, but mostly it's a 3D printed item. But I could see where that could, do some good or what have you, as long as it's balanced and it doesn't cause a run out or anything like that. Then that would, it would kind of defeat the purpose. But good question. Great question. All right, everybody. Y'all have a wonderful night. Thanks for sticking with me for 2 hours instead of an hour and a half. Sorry about that, but we will continue this. And this is a lesson. It's just not something you learn everything in one night. It's going to be an ongoing lesson. But I want to start kind of teaching you guys, not just always. We're going to eventually be out in the shop, really, too. Hands on. But I really want to start teaching you guys, setup and troubleshooting and problem solving and all that stuff, not just how to design something cool, which everybody loves. Hey, I just want to learn how to make something cool, right? I want to know how to make something and carve it. Wonderful. We're going to have those classes too. But I also want this to be value for your money, because you are paid members, right? So and it's value in learning, becoming better machinists, better carvers and all. So with that being said, y'all have a wonderful evening. JR, thanks for hanging out with me. Ron, thanks for hanging out with me. I know you had to cut out early. And Kessler, good to see you again, man. Al, great to see you. And Doug was there tonight too. I know I'm not catching everybody, but Roger, I appreciate you, everybody. So y'all have a wonderful evening, and we'll catch you on the next one.